Isomerism is the term, the phenomenon of existence of two or more compounds which having same molecular formula but the different physical and chemical properties is known as isomers, and these phenomenon is known as isomerism. Classification: there are two types of isomerism. First one is structural isomerism and the second is STEREO-ISOMERISM. Now we differentiate the structural isomerism in four parts: chain isomerism, second is position isomerism, third one is functional group isomerism, and the fourth is metamerism. In STEREO-ISOMERISM, there are two types of STEREO-ISOMERISm. First one is geometrical isomerism, and the second is optical isomerism. Now, first we study structural isomerism. Structural isomerism means the compounds which having same molecular formula but the different structures. In structural isomerism, we study first chain isomerism. The compounds which having the same molecular formula but the different carbon skeleton. Like examples, if we see that CH3, CH2, CH2, CH, CH3, CH3, then the IUPAC nomenclature 1, 2, 3, 4, 5, 2-methyl pentane. But in the case that the methyl group is in the position of third, like CH3, CH2, CH, CH3, CH2, CH3, then the name of this compound is 3-methyl pentane. So we show that the compounds, each compound is known as chain isomer, and this type of isomerism is known as chain isomerism. Second, we study the position isomerism. Position isomerism. In this case, the position of the functional group or other constituent of atoms is changed, but the molecular formula is same. CH3, CH2, CH2OH. The name of this compound is propane 1-ol. In the case of position isomerism, the position of functional group is changed. CH3, CH, OH, CH3. Then the name of this compound is propane 2-ol. Now the molecular formula is same, but the position of the functional group is different. So this type of isomerism is known as position isomerism, and this type of isomers is known as position isomers. Third, we study functional group isomerism. In this type of isomerism, the molecular formula is same, but the functional group is changed. Like CH3, C double bond O, CH3. The name of this compound is propanone because keto group is present. Propane on. But the functional group isomerism takes place, then CH3, CH2, CHO. The name of this compound is propanol because aldehyde group is present. So we see that the molecular formula of the compound is same, but the structure of functional group, the position of functional group is changed. This type of isomerism is known as functional group isomerism, and these types compounds are known as functional isomers. Fourth, we study metamerism. In this type of isomerism, we see that the chain or skeleton of the carbon is same, the molecular formula is same, but different positions and the different groups are present. Like that, if we take C4H10O, this is butane, then the two isomers of this compound is present. First one is CH3O C3H7 and the second is C2H5O C2H5. The name of these compounds is methoxypropane, methoxypropanone, and the second is ethoxyethane. Then we see that the compound molecular formula same, both the compounds, but the arrangements of carbon atoms or alkyl group is different. This types of metamerism where the arrangement of alkyl group is different but the molecular formula is same. This type of isomers is known meta-isomers and this type of isomerism is called metamerism. Now we study the STEREO-ISOMERISM. In STEREO-ISOMERISm, there are two types. STEREO-ISOMERISm is the isomerism where the skeletal molecular formula is same, but the position is arranged very different, and the compound is different. Now we study that STEREO-ISOMERISm is of two types. First one is geometrical isomerism and the second is optical isomerism. In geometrical isomerism, the arrangement of the compounds or molecules is different. Both the sides having same compounds is known as cis isomers, and when the compounds having positions between double bond different, then the compound is known as trans isomer. We see that C double bond C having two alkyl group. First the position of alkyl group is in upside, CH3H. This type of isomer where the two of the alkyl group present in same side is known as cis isomer. And when the position of alkyl group is changed, CH3 up, one CH3 up and one CH3 down, perpendicular to the carbon atom, then this known as trans isomer. This type of isomerism is called geometrical isomerism and also known as cis-trans isomerism, where the cis and trans elements are formed, isomers are formed, then the isomerism is called geometrical isomerism. In geometrical isomerism, the isomer which is used is known as geometric isomers. Optical isomerism. Now we study optical isomerism. In optical isomerism, the arrangements of the carbon atoms between both the four parallel groups is different. If we see the mirror, between the mirror, then we see that it is a mirror image of each other. That is show that CH3, CH2, C, CH3, H, O, H. When we see it between mirror, then we found that CH3, CH2, C, OH, H and CH2. They both are the mirror images of each other and is known as enantiomers. If they are not the mirror images of each other, then we don't show optical isomerism. And these types of compounds are known as optical isomers. Stereoisomerism and the structural isomerism show that the compounds having same molecular formula but the different structures, different arrangements and different functional groups between the compounds.